Hi, our names are Jacob,
and Shin.
and we are in the process of completing our fourth year civil engineering project titled The Central Pillar Structure and Earthquake Resistance, a project aimed at determining whether the central pillar design technique could be implemented into the ancient structures of New Zealand, such as maraes, to protect them from earthquakes. The Pacific Ring of Fire is the most geologically active zones on Earth, in which frequent earthquakes are experienced within the ring, shown in the red on the image on the right. New Zealand is located on this ring, making it an earthquake-prone country, which in the last 20 years has experienced roughly 40 large-scale earthquake events, including the famous 2011 Christchurch earthquakes, which decimated the city and killed 185. As a result of this, the Building Amendment Act was introduced in 2016 to enforce that buildings are better designed to withstand these earthquakes. Currently, there are various types of seismic resisting systems available, such as damping, which is a mechanism in a structure that dissipates the seismic energy experienced by the structure to decrease the oscillation of the system. Seismic dampers allow the structure to withstand high levels of external energy and reduce damage and deflections experienced by the structure. There are different types of damping systems that can be utilized in buildings, such as friction dampers shown on the left, which utilize energy dissipation through friction, and tuned mass dampers shown on the right, which oscillate in the opposite direction to the structure to counteract the movement and dissipate the energy exerted by an earthquake. Base isolation is another popular method of resisting seismic energy, which works by placing flexible material, usually made from lead or rubber, in between a building's foundations and the actual building, separating the actual structure from the moving ground. When the building is exposed to a seismic load, the flexible material stretches and compresses as the ground oscillates, thus reducing the oscillation experienced by the building by lengthening the period of oscillation and dissipating the external energy. As shown in the picture of the aftermath of the 2011 Christchurch earthquakes, it can be seen that the old earthquake building design methods were incapable of preventing catastrophic damage, and it's because of this that the Building Amendment was introduced, as well as why earthquake-resistant design needs to continue to progress in New Zealand.
Japanese pagoda has a history of 1400 years and only 2 pagodas are collapsed by earthquake in records, as Japanese pagoda features components benefit each other and form a combined system to resist earthquake. The unique part among the pagodas are the central pillar called Shimbashira, which is a rigid pillar that is flexible to account seismic outcomes. It's ideally sitting in central and on the firm base of pagoda, like a heavy bear sitting on a chair, while the surrounding features that form the study chair for these heavy bears are mentioned here. These are the SRS features in a pagoda. Among them, the snake dance is the most special theory that cancels the induced action in same axis. However, snake dance theory is only possible when Shimbashira can withstand the earthquake. As we can see, Marawi Building is the long building as meeting house in Auckland show. While from the Warane structure, it is formed by a linkage of adjacent compartment altogether, which shown as the red line here. Although our analysis retrieves one single unit and undergoes the improvement based on it. The Marawi Building is having a different uplifting structure. So we start from a simple structure with improvement, then we investigate the implementation of Marawi further. However, as the need to account the weight for uplifting design, larger beams than column are applied in analysis.
To reach conclusive results about the reliability of the central pillar technique, 2 types of analyses were designed to be completed: a practical shake table analysis and a software analysis using the computer program SAP 2000. The shake table analysis involves the construction of small square timber building frames that are designed with and without the central pillar. These frames are to then be attached to a Kenza shake table, a machine which replicates the movement of an earthquake and records the acceleration experienced at a chosen point on the structure. The idea being that the difference in acceleration or damage to the frames would allow conclusions to be made on the central pillar's seismic capability. This analysis is incomplete as of yet due to COVID-19 restrictions, making it very difficult to obtain timber. However, is planned to be complete within the next 2 weeks.
The SAP 2000 analysis is done by the dimensions specified here. Besides, the material properties and magnitude of load also specified in compliance of NG standards mentioned. To simulate a real-life event, time history simulation are employed with EL central earthquake pattern, which is widely used in global wide. Structure with different heights are tested with same width and beam weights. For each structure, Shimbashira is applied and increasing its area to observe the outcomes. In result, structure is able to reduce joint acceleration to 40% when HL ratio is less than 1. As structure height increase, the stiffness is lower, the performance of Shimbashira is getting weaker. Another fact has found as the Shimbashira sizing increase, the deformation pattern varies from type A, which deform along with columns, to type B, columns rotated. Most importantly, the spectral acceleration is significantly reduced as shown. As the Marawi Building are built on a huge base foundation, by result, the implementation of Shin can be effective. However, further research as mentioned here may require to assure its functionality. Meanwhile, the research should also focus on method implying to the existing buildings such as retrofitting, since there is a demand of current existing Marawi require an enhancement.
Shin and I would like to thank you for your time and thank you for listening. Any questions can be redirected back to us via email. Thank you.